How to load data efficiently with TensorFlow Tf.data. Imagine training a machine learning model that needs to process thousands of images or millions of text samples. If your data loading is slow, your whole training slows down too. That's where TensorFlow's Tf.data API comes into play. It helps you build fast and scalable input pipelines, so your models get data quickly and smoothly. Whether you're working on image generation with DALL-E or language models like ChatGPT, efficient data loading is key. First, you start by creating a dataset from your data source. If your data is stored in memory, use from tensor slices to turn arrays or lists into a dataset. For large datasets stored in files, use TF-record dataset, which reads data from TF-record files, a format optimized for big data. If you're loading images from folders, TF, Keras, utils, image dataset from directory, makes it simple to load images with labels automatically. Once you have your dataset, you can apply transformations to prepare it for training. Use map to decode images, normalize pixel values, or parse labels. For example, you might normalize pixel values to be between 0 and 1. Use batch to group data into batches, which helps your model learn more efficiently. Shuffling the data with shuffle ensures your model doesn't learn from data in a fixed order, reducing overfitting. Caching with cache stores data in memory or disk after the first pass, speeding up subsequent epochs. And repeat allows your dataset to go through multiple training cycles without reloading from scratch. To make your pipeline faster, use prefetch. It prepares the next batch while your model is training on the current one, reducing idle time. When applying map, set num-parallel calls to auto-tune or a specific number to process multiple data elements at once, making good use of your CPU. TensorFlow can automatically decide the best number of parallel calls and prefetch buffer size with auto-tune, which makes your pipeline adapt to your hardware. A typical pipeline for images might look like this. Load file paths with from tensor slices. Shuffle with a buffer size of 1024, map a function to load and preprocess images with parallel calls, cache the dataset, repeat for multiple epochs, batch the data, and prefetch for speed. This setup ensures your data flows smoothly into your training loop. Handling very large datasets or distributed training requires extra steps. You can split data across multiple workers with sharding, or save and load datasets with load and save. For complex data workflows, you can customize the data loading order with your own reader functions. This approach is especially useful in AI projects like training models for image generation or natural language processing, where datasets are massive and preprocessing is complex. Many productivity plugins and tools integrate these pipelines to automate data workflows, saving time and resources. In short, TensorFlow's Tf.data API offers a flexible way to build input pipelines that load data efficiently. Combining data source creation, transformations, batching, shuffling, caching, and prefetching with parallel processing makes sure your models get data quickly and reliably. This setup helps speed up training and makes deploying models more practical and effective.